polar plot. Okay, so that is in the third unit. The next topic is polar plot. I already we have discussed Nyquist plots. What is the difference between these two, Nyquist plot as well as polar plot? Nyquist plot ranges for as well as for the negative frequencies. Okay, that is from minus infinite to infinite. Whereas polar plot ranges from 0 to infinite. So next we are going to see the basics of polar plot. First, let's see what is the first, the polar plot. Polar plot is what? It is a we need to calculate what we are we are doing it in the form of frequency response. As Nyquist plot, it is here. It is also magnitude as well as angle being calculated. Okay, so which is drawn between what magnitude as well as the phase angle. That is magnitude to the real axis. Okay, and the imaginary axis we will be taking it as j omega, and the real axis we will be taking it as sigma. So what is the magnitude with respect to the phase angle? That plots will be drawn, and back here the frequency ranges from where to where? From 0 to infinite. Okay, so the polar graph consists of, in the graph sheet it will be having the concentric circles. Okay, I already shown you that how the polar graph will be, and that are in the, as well as there will be in the radial line. The radial line resembles what? For marking the magnitude. Okay, and this concentric circles for what? For degrees. Okay, that is from the phase angle towards the left hand side real part. If it is positive means that is 0 degree. Okay, so for positive degrees, so that is towards upwards, that is we will be saying it as plus 90 degree. Then towards the other opposite side, that is plus 180 degree, and towards the right and left downwards, that is plus. Okay, I am saying it in anti-clockwise direction: 0, 90, 180, 270, again 360, complete circle. With the entire thing which will happen in the clockwise direction means it will take us minus 90 towards the downside. Okay, minus 90, minus 2. Already I shown you that plot. Okay, how the polar plot will be. So this plot, for what purpose we are drawing this plot? Magnitude as well as versus with the phase angle, that is in the complex plane. Okay, so next by. And one more thing, the most important thing is by varying the frequency from 0 to infinite. And next one is the advantages. Before that, so advantages of the polar plot. So polar plot, what is the main reason for this? With the response, with the depictions of the frequency response characteristics, we are going to plot it in a single plot, and by plotting that with respect to the magnitude as well as the frequency, sorry, it is not frequency, magnitude as well as the phase angle. We will be determining what means WPC, which is phase crossover frequency. Omega PC will be saying that phase crossover frequency, and that well as gain crossover frequency. These things will be noted down, and later on what we will be doing, we will be obtaining the stability of the system. So, so magnitude we will be drawing at 0, there will be a point that will be said to be what? Gain crossover frequency. Okay, and phase where it should be crossing 180 degree. At minus 180 degree, where is the angle? That angle is said to be what? Phase crossover frequency. Okay, magnitude we will be drawing a line at 0. Where the line cross over the 0, that it is said to be gain crossover frequency. For phase minus 180 degree, we will be drawing a line, and at that point there will be a frequency. That frequency is marked as phase crossover frequency. Okay. So from here we will be taking out what? Open loop transfer function, and not with the what we will be doing closed loop transfer function. Whereas in Bode plot we need not require to convert that g of s to the, we will be doing it in the time constant form. Okay, and next, what is the disadvantages of this polar plot? Plot does not clearly indicate the contribution of individual factors. Okay, just what is the magnitude and what is the frequency that has been determined. Individual, what is how much gain, at what gain the system will be stable, that cannot be predicted by using the polar plot. Okay, so the next is so the polar plot. How we need to sketch the polar plot. The polar plot of g of j omega for the entire range of frequency wave from where to where? From 0 to infinity. And the most 4 key points are there. It starts from where? Omega is 0. So magnitude frequency ranges from 0 to infinite. The ranges of omega will ranges from 0, and the end plot will omega ranges to up to infinite. So when the plot crosses the real axis, that is said to be the crossing the real axis. At that time, imaginary axis will be 0. And the plot, if it crosses the imaginary axis, the real axis will consider to be 0. These are the 4 key points to plot the polar plots. Okay. And the next is, so here is an example one. So if you consider this problem, see, sketch the polar plot for given a first order system. Can you say yes? It is S plus 2. S plus 2 is what order system? There is S, only one. So it is a first order system. So the problem will be like this. So the given transfer function you have written it, that is g of s h of s is equal to 10 by s plus 2. First step, what we have to do? We have to replace as like Nyquist plot. Okay, but the frequency there it ranges from minus infinity to 0. So we will be taking the Nyquist contour. Okay, here no complication like that. Okay, just from alpha, omega will be substituted 0 and omega as infinite. That's it. For same step will be followed. First we have to replace s with what? J omega. So the first I am converting that in the transfer function. I am replacing the s with j omega. So in the numerator there is no imaginary term. So we can take that as 0i. Okay. So before going to the problem, let's see the procedure. Okay. So first, what you have to do that you have to check the question whether the open loop transfer function is the form of 1 plus st. Okay. If it is s plus 2 means what you have to do? You have to take the common outside of 2. Then it will be like 1 plus s by 2. So it will become 2 into 1 plus 0.5s. Sure. The first step, it should be in the form of 1 plus st. Next, what is the step? We have to replace the s with j omega. The next step will be expression for the magnitude of g of j omega, h of j omega as well as the phase angle. We know that how to find out the magnitude, that is root of real part a square plus b square, that is imaginary part's coefficient. Okay, root of a square plus b square, by substituting that we will be getting the magnitude. For phase angle, what is the formula? If in the denominator there is s, j omega term, it will be represents what? 90 degrees. Since it is the denominator, we will be marking it as minus 90 degree. If it is s square, it is 180 degree. So if it is in denominator, it will be taken as minus 180 degree. So if the term is 1 plus st, that is 1 plus j omega t, means it will be taken as, that is minus tan inverse of b by a. Okay, so b by a means coefficient of imaginary term divided by the real term. So that is how we will be determining the angle. Okay, already we have done that in the Nyquist plot. The same we are going to follow here. Only the omega ranges from 0 to infinite. That is the only changes between polar plot as well as Nyquist plot. Keep that in mind. So next, choice of frequency. We will be taking it at the corner frequency. What are the two corner frequencies here? 0 as well as infinite. These frequencies will be taken as corner frequencies. We will be substituting omega as 0 and we will be finding out the magnitude. And next we will be finding out substituting the omega as infinite, we will be finding the magnitude. The same for the phase angle. So next we will be scaling the magnitude circles. Similarly, we will be doing that in phase angles also. With respect to omega, what is the magnitude? With respect to omega, what is the phase angle? After plotting that, we will be joining that line. Okay, that plot is said to be the, what it is? Polar plot. Then the line which crosses the 0 is said to be cross frequency. Okay, crossing frequency, gain crossover frequency. The line crosses minus 180 degrees, phase crossover frequency. Okay. So the next is that is the basics of polar plot. Polar plot is a sinusoidal transfer function. We know that it is g of j omega with the magnitude g of j omega as well as phase angle of g of j omega, whose omega ranges from 0 to infinite. Okay. So one more thing in polarity, the positive phase angle is measured is what? From 0 degree. Okay. And negative phase angle is measured from the CW from the 0 degree. Okay, I will tell you that. Next is that is anti-clockwise direction and clockwise direction. Okay, that is CW is what? Anti-clockwise direction 0 degree. Whereas the negative side will take means clockwise direction 0 degree. Okay, I already told you that. Okay, so the next is Next is the problem, the basic problem with order 1. So here it is. So first, after taking j omega, we have converted it. Okay. So next, what we will be doing? We will be marking that as this is as a. Okay. Here there is no. We will be taking it how? That is a plus j omega. Okay. So a plus b is here omega. So can we find out the magnitude? So magnitude will become 10 divided by. So a minute. Magnitude will become 10 divided by, what is the denominator? A square root of a square plus b square. What is a square here? Omega square. Plus what is b here? We can rearrange it also. Okay, you can write it as 2 plus j omega. Okay, or you can take that 2 as common outside. That is the first initial step. If 2 as common outside, we will be taking it as 1 plus s by 2, j omega 2. So it will become 1 plus 0.5 j omega. Okay, so we can take that 10 by 2 will calculate, you will getting cancel. So that will become 5. Okay, you can find out in such order also. You can, since it is a single order system, we have done as like this. Okay, so it will become 10 divided by root of omega square plus 4. So it will become what? This is the magnitude now. Okay, next angle means what will be doing? For the numerator, the angle is 0 since it is a constant 10. For the denominator, what it is? 2 plus j omega. We can take it as tan inverse of omega by 2 here. Okay, so if I take this denominator to the side, means it will become minus tan inverse of j omega by 2. Okay, so now we know the limits. What is the limit for omega? 0. That is 1 crossover frequency. Another corner frequency is infinite. So first I am substituting that omega as 0. So what will be a magnitude will become 10 divided by, if you substitute omega as 0, it will become root 4. That is 10 divided by root 4. Root 4 is what? 2. So if you substitute that, 10 by 2 will become 5. So for when omega is 0, what is the frequency there? Sorry, what is the magnitude there? 5. And next, the angle. Angle will become minus tan inverse of omega by 2. What is the value for omega? 0. So tan 0 is what? 0 degree. Okay. And next, when I am substituting omega as infinite. What is the magnitude? 10 divided by root of 4 plus infinite square. So it will become 10 divided by infinite. So that will become 0. 4 by infinite, which is 0. Okay. Likewise, angle tan minus tan inverse of infinite by 2. When this tan angle is infinite, 90 degree. So it will become minus 90 degree. Okay. So now you know we have to plot, that's it. The real axis when omega is equal to 0. When omega is 0 here. The real axis when omega is 0. What is the magnitude we found out? It is 5. Okay. So it is when omega is 0, it is what? 5. Okay. So it ranges from where? From 0 to infinite. So at infinite where it is 0. Can I get my point? How what I am saying? When omega is 0, the magnitude is 5. We will be marking it over here. Okay. And next, the angle is where? The angle is where?
90 degree.
The angle initially when it is 5, the angle is 0. Same line. Okay, so when the magnitude is here, when the angle is 0 here, okay, next, when the magnitude is 0, what is the angle? Minus 90 degree. Minus 90 degree means where it comes? Over here. Okay, so from 0, magnitude is 5. Okay, we will be marking that in the graph. Here it is marked as 1, 2, 3, 4, 5. Magnitude 5. Angle is 0. Okay, and from there to when omega is infinite, what is here? It is minus 90 degree. Okay. When omega is infinite, it is what? Minus 90 degree. So minus 90 degree is here over here. So we will be marking it over here. So this is how the polar plot will be for a single order system. Okay. So the next is. So one more problem example 2. Here it is having one more poles are there. Okay, that is g of s h of s is equal to 10 divided by s plus 2 into s plus 4. So the same here. Next, what we have to do? 10 divided by s plus 2 along with the 2 is there, s plus 4. Okay, so the same we are going to follow here. That is magnitude of 10 divided by, it will be the magnitude means root of a square plus b square. What is a here? Omega square. B is 2 square, which is 4. Likewise, root of omega square plus 4 square, it will become 16. That is the magnitude. Next, phase angle. In numerator there is only 10, so that will be no angle. It is 0 degree. Then denominator, what it is? Tan inverse of omega by 2 plus tan inverse of omega by 4. You have to don't take from here. Okay, consider this question. From the question only you will be plotting the angle, phase angle. Okay, so it will become tan inverse of b by a. B is what? 2. A is what? So sorry, here in the crossing here, you have to cross this and write 2 plus j omega. Real part plus imaginary part. So it will become omega by 2. Okay, so this is the real part will be the A, imaginary part will be the B. Formula is tan inverse. Tan is opposite by adjacent. I already told you, opposite by adjacent, that is omega by 2. Okay, so here, so it will be written as tan inverse of omega by 2 plus, again here tan inverse of j. B is what? Omega. Omega divided by A is 4. Okay, so it is in the denominator. So if you take to the numerator, it will become minus. That is minus tan inverse of omega 2 minus tan inverse of omega by 4. So we have to know very what? Range of frequency omega. What of frequency? One is 0 and the other is infinite. When omega is 0. First, what is the magnitude? If you substitute 0 over here, it will become 10 divided by root of 4 into root of 16. Root 4 is 2, root 16 is 4. So if you cancel it, what will it become? 1.25. And same for the omega 0, what is the angle? Minus tan inverse of omega 2 minus tan inverse of omega by 4. Tan 0, it will become 0. And next, omega is infinite. So it will become 10 divided by infinite. 10 by infinite is 0. Anything by infinity is 0. And next, angle it will become minus infinite, tan inverse infinite, minus tan inverse infinite. One time minus tan inverse infinite, what we know? 90 degree. When tan is infinite, 90 degree. Okay. So one minus 90 degree, other one minus 90 degree, which will become minus 180 degree. So if I plot here, it is what? Minus 180 degree in the clockwise direction. Okay. So already told, negative angle clockwise direction, positive angle anti-clockwise, ACW, anti-clockwise direction. So here 0 degree, minus 90 degree, minus 180 degree. How our plot will be? What is the magnitude here? 1.25. Okay, you assume this as you can mark it since it is 1.25, right? You can take it as 0.5, 0.25. Okay, 0.25, 0.5, 0.75. Can you get my point? For one scale, what I am doing? For 1 centimeter, I am taking it as 0.25 unit I am considering. So it is 0.25, it is 0.50, it is 0.75, it is 1, it is 1. It is 1.25. Okay, so 1.25 omega is 0 here. So from 0 to, when omega is infinite, what is the angle? Minus 180 degree. So it should touch the next one. Okay, so this is how you will be plotting the polar. Can you clear with the second example? So the next is, so for various problems, let's see your examples. Okay, how it will be. If it is type 0, just one order. I already told you this problem. Order, there is only one order. Type is 0. Okay, so the polar plot will be like that. Okay, so if it is type 1, that is S into order 2. Okay, the polar plot will be like this. That is, if you substitute that g of j omega, so if you take the magnitude, it will be like 1 divided by omega into 1 plus omega square t square. The t square will be any value, 2 or 4 or something like that. Okay, or 0.1. So if we substitute that omega is 0, omega is infinite, what will be the magnitude and what will be the angle? So the polar plot will be like this. For type 1, order 2. This can be asked as 2 marks also. type 1 order 2 how the polar plot will be. You have to write this equation and you have to determine the angles. Okay, and the next is for type 0 and order 2. The polar plot it comes from where means from 0 to minus 180. We have seen a problem over in this example. Okay, and next for type 0 order 3. So the same plot will be remain here. Okay, so that is one more 90 degree will come, right? This is a minus 90 degree and another minus 90 degree. If I take the angle, what how it will be? Minus 10 minus 90 degree, minus 90 degree, minus 90 degree. So it will become minus 270 degree. So the polar plot starts from whatever the magnitude, you have to mark it from there to minus 270 degree. Get my point? And next is type 1 order 3. So type 1 order 3, the graph will be like this. That is from 0 to x minus 90 degree. This side. Okay. So next is for type 2 order 4. Okay, so type 2 order 4 means s square. Here this is the what? Without multiplying the s inside, it is what? Type. So here it is s square means type 2. If I multiply the s, it will become s power 4. So order is 4. So how the magnitude? How the angle? So here it is minus 180 degree. Again minus 90, minus 90. So it will become minus 360 degree, right? So where it will comes from here it is a minus 360 degree. This angle, if you see that, what it is here? Minus 360 degree, right? From here to, it will come over this side, that is minus 180 degree to 360, minus 360 degree. Okay, and next for type 2 order 5, how the polar plot will be. One more minus 90 degree will come. So one more minus 90 degree towards here. Minus 90. Okay, that's all. So for various types and various orders, how the polar plot will be, how the magnitude, how the phase angle. Okay, if you go through it, you will be getting clear. Clear with it? Is there any doubt here? So next is the stability of the polar plots. So to state, as I said here, right? To state the stability, what you have to do means unity circle you have to draw. I told you in the 90s plot. When it is stable, minus 1 plus j0, which is left hand side of the S plane. If you are saying it in S plane, it will be left hand side of the S plane. If I am saying it in GH plane, it should be in the form of minus 1 plus j0. That's what I told you, right? Minus 1. So we will be drawing the encirclement. I told you that is the unity circle. Okay. So if I mark the here I have marked it, right? So there is a magnitude and how the polar plot goes. If my points lies inside this, okay, inside the unity circle, okay, then we will be saying that the polar plotting shows the positive gain margin as well as phase margin. Okay, so unity circle is now here. Okay, our point B, the level which we are where we have marked the magnitude. If it is stay away from the magnitude, so then it is said to be this negative gain margin and the negative phase margin. So in order to calculate this gain margin, what it is? The gain margin is the inverse of magnitude. At where means the phase crossover frequency, and it is at what we are told it at 180 degree. Okay, and next is the phase margin. It is what means 180 degree plus already we have calculated the gain margin. So the phase crossover frequency at the gain margin 5GC. If I added it, I will be getting the phase margin. Okay, so that is gain crossover frequency is the frequency at which the magnitude is unity. Okay, so that is how we will be determining the stability by using the polar plot. Okay, is there any doubt here? So that is all about your polar plot. You can now draw it for various types, various orders, just by predicting the omega 0, omega c infinite. Okay, so that is all about polar plot. Try different problems.